ตอนนี้ทาง CHC เข้ามา2 account แล้วใช่ไหมครับ
ครับเดี๋ยวยังมีอีกหนึ่งครับยังมี
อีกหนึ่งนะพี่นะ
หนึ่งaccount อยู่ที่ออฟฟิศครับหนึ่ง account อยู่ที่ไซต์ที่ลาวครับแล้วมีหนึ่งaccount อยู่ที่ออฟฟิศของกองทัพครับ
ครับเดี๋ยวพี่ประพันธ์จะ introduce ฝั่งพี่ก่อนไหมครับในฟังก่อน
ครับ
เชิญเลยครับพี่ประพันธ์
Good afternoon Mr. Jin
Hello, good afternoon.
Okay. In our side, CSC, I am Prapan, and it's Kun Puchong.
Kun Puchong, hello, how are you?
And Kun Walawa.
Kun Walawa, hello.
And Mr. Walita. And
Mr. Walita.
John Kwan. Another one is Kun Wongsathit, is probably is our consultant.
Okay.
And our project manager, Mr. Itikon, as Lao Science.
Good afternoon.
Nice to meet you.
Yeah, I also have my team here behind me here.
Mm-hmm.
Hello, everyone.
Hello.
So nice to have the meeting. So my name is Hong Jing, or Jing Hong Jing is my family name, and I'm now the sales manager for Asia Pacific area, and also we have also a lot of cooperation with our Siemens Energy Thailand. We have served the market with overhead line surge arrest protection for many years. And today also I have invited our engineering colleague who is the EGLA expert, Mr. Kumar. And
hi everyone.
So to join from the Berlin side, we are just working in the headquarters in Berlin. Good. And so Kun Claude, let's start today's meeting.
Yeah. My name is Songkot. Yes. Last week I met Kun Mapan and Kun Puchong at the office, and it seemed that there are many questions that myself and our customer would like you to clarify. So, what shall we start, Hong? Can you present our product in short and together with the study that you already submit?
Yes, sure, of course. So we can just now provide a shortly presentation about Siemens overhead line and products and the solution. Wait a moment.
So may I talk in Thai sometime now, Hong?
Yeah.
In case that we need some more detail or some more further question. Sorry.
Okay. So if you allow me that I just now make a very short presentation what we have the solution for the overhead line production. And so this is my personal information. And Siemens Energy surge arrest, we have roughly 100 years history. Yeah. We started now the over voltage protection device since 1925. And until this year is roughly 99 years. And our company was founded in Berlin, in Germany. And here is the center of Brandenburg Gate. It is the center of Berlin. This is also symbol of Germany. And this is our comprehensive portfolio. Most today's focus will be overhead line, surge arrest and insulators. And of course, we have conventional substation arrestor and the insulators product. And we have a lot of business in the HVDC FACS arresters. We have medium voltage arresters, and also for the GIS and also railway application. So for overhead line surge arrest, it's very, very important to have such a surge arrest protection. Here, I just wanted to show a short video. I hope that the playing go to Thailand will be smoothly.
Is it no sound?
Unfortunately, that is the sound is not so easy to transfer to your side. But this is most important is the video, the picture. It shows also 3 times the same flash over on the insulator. So if you now the lightning strike on the overhead line on the shearing wire or also on the tower body itself, then the the insulator will suffer a very high over voltage. And if we have now also very critical footing resistance, and it will often lead to a flash over on the insulator. Just like the video shows, this is one flash over and with 3 slow motion playing. And you can see each time of the flash over on the insulator, it will lead to a tripping failure on the overhead line. At least the circuit breaker from the power supply side must be opened and to cut off the short circuit current on the insulator. And if now the insulator has been damaged permanently, and then this overhead line will not be able to put into the operation again. So this is the very high danger caused by the lightning over voltage. And how to just summarize now the basic reason for the flashover. So flashover will always happen on the insulator across the both ends of the insulator. And the most probably the cases is so-called back flashover. And back flashover, the principle is like this, that if we have a tower with a very high footing resistance, and when the shielding wire received the lightning strike, the energy cannot be discharged to the ground in very short time. Now we are talking about microseconds, very, very short duration. And in such a short duration, the insulator will receive very high overvoltage. Because we have a high footing resistance, and then the inductive voltage drop across the closed arm to the transmission line will be over the basic insulation level, and it will lead to the flashover on the insulators. Since the energy try to go to ground but cannot discharge quick enough, we call it back flashover because the energy will go back to the closed arm and it will establish over voltage across the transmission line. And another cases will be, we call it direct stroke. So which means if we call it also shielding failure, which means if we have shielding wires on the top, but the lightning come to a very low angle, and it can strike directly on the transmission line, not on the shielding wire or on the tower. Then this is very high energy will be rushed on the transmission line. It will be traveling from the hitting point to both sides, left and right. And this high energy will also build up a very high over voltage across the closed arm and the transmission line, which lead to the also the same problem of the flashover on the insulator. So both case, back flashover or the direct stroke can be avoided by the surge arrestor itself. So if we install the line surge arresters in parallel to the insulator, when the lightning strike come again to the tower or to the shielding wire, and this overvoltage will happen across the cross arm and also the transmission line, and very quickly, within a microsecond, the surge arrest will be active, which means the surge arrestor will be conductive to discharge the current from the cross arm to the transmission line, and to limit the overvoltage, because the surge arrestor has a residual voltage, and there is a residual voltage can limit the overvoltage below this level. We call it the level is protection level of surge arrestor, and it is much lower than the insulator withstand voltage. So with such a surge arrestor protection, if you installed enough quantity of the surge arrestor on the tower for each or some of the insulators, you can reach to a target to reduce the tripping failure rate to a very lower level or even to zero. Yeah. We have a very good example from some countries like also South Korea. South Korea, the state utility is KEPCO, KEPCO, Korea Electricity Corporation, yeah, Limited, and they have installed more than 200,000 pieces of EGLA on the transmission lines. And until today, they have benefited a lot, and they can reduce the tripping failure close to zero, yeah, to avoid any such a flashover problems on the transmission line. So moreover, if we're using the line surge arresters, so basically we have two designs. One is a non-gapped design, non-gapped line arrestor. Then another one is the EGLA is with external gapped surge arresters. So left and on the right side, you can see the difference. NGLA is non-gapped, which means one side will be connected on the high voltage transmission line, and another side through a grounding conductor, and a disconnect will be connected to the grounding point of the tower body. And the right side is EGLA, externally gapped line arresters, and which means we have one or two surge arrestor as the SVU. SVU is the shortening of the series varistor unit. And we see SVU, it can be two part or the one part of different design. Yeah. At the middle, we have a certain gap. This is air gap. And this air gap will avoid now in the normal without overvoltage the situation to avoid the leakage current, because there is no current pass across the surge arresters. And only under the lightning strike when the overvoltage comes, and this air gap will be sparked over by the high voltage from the lightning. And then the surge arrestor will bypass the energy from one surge arrestor, go to the arcing current at the middle to the another side. And in such a case, that both SVU or the one SVU will have also the residual voltage, and this residual voltage can limit voltage drop from this point to the another point, and this will limit the lightning overvoltage on the very low level. For example, it will be under roughly 60% or 50% lower than the basic insulation level of the insulator. So in such a measures, you will never have the flashover on this insulator again. So this is non-gapped surge arresters. Non-gapped surge arrestor, which means you have constant voltage applying on the both end. One is from the high voltage. Yeah. If you see the right side of the picture, this is hanging on the transmission line, a 500 kV non-gapped surge arrestor. And another side of the surge arrestor will be connected to the tower body, the grounding point. Yeah. So it will protect the insulator here. If you see, this is insulator for the transmission line. So for the non-gapped surge arrestor, it will, like a normal substation surge arrestor, it will take a certain quantity of the MOV inside. It will withstand constantly operating voltage, and it has a certain requirement for the withstand voltage and also for the creeping distance, pollution level, and so on. So on this page, you can see different installation place of the non-gapped surge arrestor on the transmission line. For the voltage level below 170 kV, in Canada, we have also delivered for the 245 kV. The surge arrestor can standing on the close arm or hanging below the close arm. Yeah? And another side will be connected to the transmission line. And for the extra high voltage, more than 300 kilovolt, and the surge arrestor should be hanging on the transmission line. For this design, NGLA, this is well known also the fatigue problems, because the disconnector is a necessary mandatory element. If the surge arrestor is failed, then we should cut off the permanent grounding point here. Then the disconnector should separate the circuit. But the mechanical part of disconnector will face also mechanical fatigue failures, because on the towers, under the wind position, under the high vibration situation, there is a lot of fatigue effect on the disconnector. And if also some cases will be the incorrect installation of the grounding cable, because it will be connected to the grounding cable, then the disconnector always under the mechanical tension. It will lead to even heavier fatigue failures. So the surge arrestor itself is still okay, electrically is still okay, but the disconnector itself will be disconnected by mechanical force. So it happened many times in different countries and different customers. From Siemens side, we have a very special and patented design to avoid such a fatigue problem, which means we have a 3D flexible movement system for connection of the disconnector to avoid the mechanical stress or the tension on the disconnector itself. So, moreover, we need to talk about EGLA, EGLA. So EGLA, we have now for this picture, you will see we have active part SVU and plus one gap. And the EGLA can be also used for the voltage level up to 800 kilovolts. So this is our standard configuration. It can designed for 20 kiloamps discharge current. And also the charge transfer QRS will be 1.8 coulomb for the normal operation case. And the thermal energy WTH will be 14 kilojoule kilovolt. For the benefit of with this design is how to say, we have no disconnect because we have air gap. Therefore, even the surge arrestor itself is failed under the overloading, but there's no short circuit current can happen here because of the air gap. And we have now not the permanent or constant voltage applied on the surge arrestor itself. Therefore, the configuration of the surge arrestor can be less material used and less manufacturing cost. In comparison to the NGLA, the EGLA type is much cheaper, and also the weight of the EGLA is lighter, which means for the closed arm, we have less weight loading. Yeah? That is also one benefit. And also the very important benefit is no leakage current. And therefore, in normal condition, there's no galvanic current pass for the leakage current. And there is also no such aging behavior on the surgery rest itself. And this is also suitable for the multi-circuit towers with closed arm, because you see it can be installed integrated on the insulator itself. It can save a lot of space. Yeah. We don't need to have installation in parallel to the insulator. We can save the space on the tower. So this is how the EGLA works. As mentioned before, if we have received now the lightning strike, the lightning overvoltage will travel to the insulator and produce the overvoltage from both ends of the insulator. In such a case, that the air gap will be sparked over, and then we have now the surge rest active. The discharge current will go from the one surge rest through the arcing to the another one. So from this curve, you can see the working curve exactly. After that, we have a follow current, because the arcing current should be extinguished. And this extinguishing will be tested by the follow current interruption test. It's belong to the type test. We have many applications. We have delivered more than 200,000 EGLA in the world market. And one example is also like this case in Lampraban is 500 kV EGLA. We have delivered to Vietnam. And in Vietnam, there is some simplicity, because they have V string and also tension string only two type of the surgery, two type of insulator. So this is the picture taken from Vietnam transmission line after installation. This is V string, and the surge rest can be installed at the middle. And this is electrode, and another side is high voltage electrode here, like the corona ring. And this one is on the tension, on the tension strings. And if we go back to the drawings, on the last picture, you will see this is a tension strings. And we can use the adapter installed the surge rest on both sides, on the hardware of the insulator strings. Here is, you see, this is the bracket provided by local EPC. Yeah. And then we have now a platform to install the surge rest on the tension insulator. So for the other installation method is also many cases in China, because in China there is a big area, especially the area like Sichuan or like Guangxi is near Laos, and they have a very similar climate situation to Laos. And because of they have many different type of the tower, and how to make a standard design for the EGLA to fit all different configuration of the tower. If you see, this is also the configuration of the tension tower. Yeah. And they have both sides tension insulator. At the middle, we have a jump insulator. And it's for the customer, they want to have a one standard design to fit all different tower type. And therefore, we in China, we have such a design with a flexible connected surge rest and a long load insulator as a gap holder. Because the gap must be stable. The gap means if you have a stable gap distance, then the working condition of each spark over will be also constant. Yeah, will not be variable. it is guaranteed for the working station of the EGLA. So in those areas, if you have permanently such a strong wind force, and to avoid such a swing of the conductor or the jumper conductor, then we have used one long loading insulator and to hold both electrode here. One side is from high voltage, another side is from the surge arrestor. And this is the gap distance here. It will be fixed by the long loading insulator. With this standard design, we can use for all different towers using one design. Yeah, not like this one. This one is always a customized design. If you use for the V-string, then we have one assembly of the surge arrestor. If you use for the tension string, then we have two different SVU. Two surge arrestor will be separated, but the electrical configuration will be the same. Yeah. Well, as we just read the drawing from the Lao Prambang, and then we will see that in this transmission line, what we are talking about, they have even more different transmission towers and also more different insulators. Not only V-string, they have also double suspension, single suspension, and double tension and so on. So this is also the question where we need to install the surge arrestor as protection, and on which phase, and also how can we simplify now the logistics process, and later on also the installation process. Yeah. So here is some short summary about the advantages of EGLA. So first one is cheaper and less material. Second one is no leakage current. Third one is no ground lead, no disconnector is needed. And they cannot be failed due to the line fault. And also very important is no maintenance monitoring required because there's no leakage current. Yeah. So if you have a very big quantity of this surge arrestor installed on the transmission line, and to make the regularly monitoring work is also very, very hard workload. If we use the EGLA, there's basically no necessity for the monitoring. Then we can save a lot of workload for the operation. So here is many, many different cases what we from Siemens Energy delivered EGLA in the world market. It can be integrated on the insulator like this one. It can be also extended from the side. This is for EGAT in Thailand. Yeah. And also we have delivered 800 kV EGLA for USA. So all those different kind of design. And this design is what we have delivered to Cambodia. So following is our long loading insulator products. I just present very short information to you. Yeah. We have started the long loading insulator and also post insulator product since 2011 using the same technology like the surge arrestor, polymer surge arrestors. And currently we have the product in our portfolio long loading insulators and also post insulators. We use a very high quality material. Yeah. At the middle, the core material is ECR FRP rolled, electrical corrosion resistant fiber reinforced epoxy plastic. And overall, that is the direct molding of the silicon rubber. And this silicon rubber is high temperature vulcanizing silicon rubber, HTV, high voltage vulcanizing silicon rubber. Yeah, it's our standard technology and the material. And both sides, we have also the forged steel and the cast iron as the end fitting. So for long loading insulator for the transmission lines, the most critical point is the joint here, because here is the crimping point between the core material and end fitting And here is also most critical point that get the moisture ingressing or make such inside partial discharge, electrical corrosion. Those point is very, very critical, must be protected very carefully. So all we have over molding design. After crimping of the core material and the end fitting, we will use over molding silicone rubber to completely cover the joint point to avoid the moisture ingression. This is our special design. We will also deliver, if the customer required, to deliver the metal hardware together with our non-loading insulators, cooperated with different supplier. So we have served also the world market since 2011. We have delivered many and more than 600,000 pieces of non-loading insulator in the world market. So here is my short information about our product. But I think that next we need to also talk about where and how we can install the EGLA if we are wanted to protect now the current 500 kV. Yeah, this transmission line with EGLA. And yeah, Sungkrata, yeah, please.
Yes, I think that the customer submit you like a first draft information. So please let's say what you can do by using the first draft that you receive.
Yes, okay. And so wait a moment, I just try to open now the join
and also please touch a bit regarding the study and that you introduced for the project.
The life study is our opinion. It is the mandatory first step before we even set up about how many quantity should be also installed and which target we can reach with this project. And then we will see next step is based on the line study result, where and how many surgery towers should be equipped with the EGLA. So as we see, we have seen, let me just share now the reply from the customer side. So we have a questionnaire for the line study. As I mentioned, the line study is the mandatory first step to sales. We have so many towers on this transmission line. And for each towers, we needed to have the footing resistance, geometry, dimensions of the surge rest, and dimension, and also the technical specification of the conductor, also as well as the insulator itself. Those data will be needed for input in our line study. So I have sent an example of our last line study, the line studies report as a reference. So this is actually for Hongsa hydropower plant. And they also has the request to do the line study, and we have done the line study for the customer. And based on those customer input, and this is basically what we have already seen, what is the principal reason of the back flashover or direct stroke as the most probably cause of the flashover. And then we have now those details from the customer. What is about the location of transmission line? And where what is about now here, the geographic area, and how high is the lightning density in this area. And then we get also the geometry dimension and the conductor dimension from the customer. And we can run also with our simulation software, Sigma SRP. So this is the basic information from Hongsa to Nam, and we received all those data from the customer. And also the current situation without the surge arrest production, how heavier is now the tripping failure, and so currently, and before the equipment of the EGLA, they have 15 flashes per square kilometer per year, and this is ground flash over density. Then we have many fields to be filled out with the data from the customer side. We needed to have a span dimension. We needed to have also the footing resistance value, and so on. All those data must be provided by the customer with the current measurement. Because as we know, some footing resistance will be changed from year to year due to a different soil quality, or even the underground level that will be also have the influence on the footing resistance. And as a reliable basic for the line study, we need to have the actual data.
Sorry, Hong, for interrupt.
Please.
I think that the customer has the question on the data for your input. In case that it is the first data, it is not the final one. Can you take it for running or for studying?
Yeah, as I mean that if we receive the obsolete data, then the result will also not reliable.
Yes,
this is the fact. So if the customers provide only the existing data to us and to say, you can do just a line study, we can do it. Whichever the data the customer provided to us to say this is what we can provide, then it will be the basis for the line study.
It's like a first studying.
Yeah, first study.
Yes. In case that they would like to decide if they would like to reduce the tower resistance, and then giving you again for the new one, so you can do the restudy again.
The workload for the line study starting phase is a very high workload. So my colleague Kumar is responsible for the line study in our headquarters in Berlin.
Yeah.
And Kumar, maybe you can share your experience. So if the customer provide what currently available data, and you started to prepare the line study, it will take several weeks times. Of course.
โมเมนต์ Hong พี่ประพันธ์ผมถามถูกไหมว่าพี่อยากจะได้ study first ครั้งแรกก่อนใช่ไหมพี่อย่างนั้นใช่ไหม
ใช่ครับแต่ว่าเรายังไม่มีค่ากราว resistance นะครับตอนนี้ footing resistance ยังไม่มี
ครับค่าที่พี่จะให้นี้หมายถึงว่าค่าที่วัดได้ตอนนี้เลยถูกครับ
ซึ่งถ้าตอนนี้มันจะสูงเกินซึ่งมันใช้ไม่ได้อยู่แล้วครับเขาลิมิตไว้ไม่เกิน5 โอห์มเมตรนะครับต่อ1 tower นะครับ5 โอห์มเมตรทีนี้เราอาจจะทำใช้วิธีทำกราวแบบเมืองไทยก่อนนะครับทำ gravity material ทำ cotton voice ก่อนซึ่งเราก็ expect ว่ามันจะประมาณไม่ถึง5อยู่แล้วนะฮะอาจจะสมมติว่า10 หรือ 15อย่างเงี้ยนะครับสมมตินะสมมติว่า10ถ้าเราให้เป็น10 องค์ไปก่อนเนี่ยมันจะstudy1 รอบจะได้ไหมนะครับ
ไม่ผมพยายามจะถามเพราะว่า เขาจะสตาร์ทให้เราได้กี่รอบถ้าสมมติว่าเราจะจ้างเขาใช่ไหมพี่ผมถามถูกนะ
ถูกครับแล้วก็ไฟนอลอีกรอบหนึ่งซึ่งผมต้องดูก่อนว่าเราจะจริงๆเท่าไหร่แล้วค่อยมาดูว่า
โอเค
จะดีไหมพี่
ครับโอเคฮง so please let the colleague present how you perform study because now the customer they have the first draft before improvement of the tower resistance. So the question is if you take this data for studying and then you feedback with the result and then it seems that a lot of EGLA required, so it is not good for them. That's why they would like to make a decision and to do improvement on the some tower resistance.
So if you see now the first feedback from the customer, this section 2, all those my understanding is CTEC and PWH is different measurement device, maybe, right?
No อันนี้คืออะไรครับพี่ประพันธ์ CT EC กับ PWH
CSC column
CTEC column
CTEC yes
Mm.
and this is the initial ground resistance but not yet improved.
Not yet improved. And
Yes.
you have started the improvement now for those tower, right?
After we construct the foundation, we do the foundation. So okay, please คุณผู้ชม
This line is under developing. Just such survey only, not finished line. From your previous study, the line has been finished. This measuring is a soil resistivity, measuring in ohm meter, but we are down the figure right now. We will try it again. Get the exact accuracy. We are not sure the measuring method that our subcontractor submit to us. This got 13 kilometer only first section.
So basically to say those footing resistance is much too high.
Yes.
And our experience, so when the footing resistance more than 10 ohm is starting to be critical, which means also back pressure over risk will be increased dramatically. When the footing resistance more than 10 ohm.
Can go back to your study for USA project first.
Yes.
To specify the requirement from the construction specification. Our requirement from the owner is that they need the tower.
We have a questionnaire. In questionnaire, we have listed all those required data, including the tower configuration, also the footing resistance for each for each tower, and with those input of the data. And because it will take a very long time to prepare now the modeling of the line study, to get all those data from your side to be input in the software. This is the first step. And then if we finish the input and we will start the running of the software simulation, it will take several days.
So you need the final tower ground resistance, right?
Yes. If you see, this is Hongsan. At that moment, we received the Hongsan footing resistance. So for some Hongsa towers, they have roughly 90 ohm. And for us, that is 5 ohm is a critical line, which means we can input all those footing resistance in the software. And thereafter, we will see also, you will see the result from last line study for Hongsa. With footing resistance about 5 ohm, the back pressure over rate starts increasing. So basically, those towers must be installed with surge arrestor to to avoid the flashover. This is the line study and what we have get now from Hongsa project. And for your project, it will be the same. If you give us all those existing data of the faulting resistance and the configuration of the tower, and we put in the software, and the software will produce such a diagram. Yeah? And to say it's from tower 1 up to tower 200, and what is now the situation of the faulting resistance. And we will also make the simulation. Finally, you will see, we will give feedback to you on which tower and how many pieces of the EGLA should be installed on this tower, and you can get to which target.
Problem is that right now we start from the green field. Nothing. We can get
Yeah,
the resistance of the tower after we finish the foundation work of the transmitter line. We expect to be we start construct the foundation early next year.
early next year.
Yeah, Hong, I think it is different between Hongsa and for this project, Hongsa is the line already done.
I finished already.
Yes, and then they
This
can give
this
you the
transmission
final.
line is not in the operation. No?
For this project, not start yet for the tower.
Yes.
Okay. So the construction of the transmission line has not been started.
Yeah,
No,
correct.
we start early next year. Start next year.
Okay.
Foundation finished, then we can take the measuring of the tower resistance. After
Frankly to say, with currently now very vast the data from the tower, we see that is not a solid fundament for the line study, because the line study will speak nothing. Yeah, but only one thing is certain, that if you install the EGLA together with insulators on those very critical towers, and it will help you to reduce or even eliminate the flashover. This is definitely.
You're right.
As an example, I just share with you, we have also a project in Australia, and it's roughly 600 kilometer long, is 500 kV. Yeah? And also they want to install with 500 kV EGLA for 6,000 pieces. 6,000 pieces EGLA, they are make the budget. Because also very, very bad geography situation. They have in this area very, very rocky soil, and they have a very high footing resistance. So if you install the EGLA on the towers, then you don't need to reduce the footing resistance. You can save a lot of workload and money to reduce the footing resistance, because now if you install the surge arrestor on the towers, and then the flashover will be protected by the surge arrestor itself.
Yeah, Hong, I think it is the question that the customer would like to ask you. By using the first draft, how can you suggest which tower should be installed? Can you advise?
It's too early.
Too early.
It's too early.
Ah,
For any line study, we needed to have solid data input.
yeah.
Yeah, hi everyone. Yeah, this is Kumar this side. I also want to add some input on the line study. So I have, until now, I have also done multiple line study for a different system, like for other different countries and the different, I can say, geographical locations of the transmission line. And from that experience I can understand that whenever I perform that study I get a very different result each time, because this line study depends on the inputs what we give to the system. Like we need the system data and the geometrical data of the conductor, then what is the span between two tower gap, and also it varies based on the tower footing resistance. And yeah, definitely, as Hong mentioned, that if we installed our EGLA in parallel to insulator, we don't need to take care about reducing the tower footing resistance, because the when we install our EGLA, it will take care of that back flashover phenomena, which generally occurs during the lightning activity, which is, I can say, by the most probability of occurring a lightning flashover across insulator will be from back flashover only. But if we just protect our insulator with a lightning arrestor, there will not be any back flashover in the system, so we don't need to then worry about the reducing tower footing resistance.
Yeah, may I ask question? May I share my
Please.
idea?
Yeah,
Yes,
Please.
let me explain for a big picture for this project. The client who is contacting you is the position is the contractor, not the owner. The, this, the we can say that the problem of the contractor for this project is the specification. The specification, I mean, mentioned quite strange that there is no item for pricing for the third arrestor, but they just put in the specification of the tower improvement that if the tower footing resistance cannot reduce uh, uh, to 5 ohm or less, the contractor have to install the third arrestor on the line. But there is no price item to quote for the price or the cost of the third arrestor in the bidding. That means at the end is frankly speaking is that would like to give you advice to think about how to minimize to install the third arrestor in this line. This line is double circuit. Based on your experience, is it possible that we are focusing on installation of the third arrestor on just one circuit, like we do the unbalanced installation on this transmission line? Okay, finally, the client have to accept. Is it possible that we install just one circuit? Or this is my question. You may have several choice in your experience. We asked you to provide us with a minimize installation of the service on this line. For example, we don't know the span length is a factor or not. The nominal span length for this project is 440 up to 450 meters, but the actual length maybe varies from this. Is it possible that the 1/3 arrestor can cover the range more than 2 or 3 towers, back and ahead span, something like that, that we can share the performance or the effective performance of the service to cover more than one tower, not just depends on the footing resistance, something like that.
No,
Okay.
unfortunately not.
Yeah.
And so our line study and also the thesis and has also many study for those cases. And it is recommended to say if you have a high putting resistance on one tower, it also will be recommended to install the EGLA or the line surge arresters on the neighboring towers, because the neighboring towers, even they have a less putting resistance, but due to the back flashover effect, they will be also increased with the flashover risks. So it's better to say not to install on one tower to cover the neighboring. But if you have one critical power tower, then you need to also install the EGLA on 3 towers, left and right.
Mhm.
Yeah, the line study result speaks for those recommendations. And from this table, what we have seen, basically you have not finished the tower, but you have a very high footing resistance for the suggested installation place. And we will see all those is very much too high, the footing resistance, if you install the towers on those places. Of course, that is also make a mechanical and technical sense that if you don't improve or reduce the footing resistance in those places, and you can use the EGLA to avoid flashover on the insulator, that make technical sense. It's true. And but for those, I see that is section 2, 16 in total 31 towers. And for each towers, our recommendation is so better for a very good protection on the tower. You need to install 3 up to 4 surge arresters. And it's not all those surge arresters on one circuit, but will be distributed to 2 circuits, but especially the bottom and the middle phases. If you have left one circuit, right one circuit, our circuit consists of 3 phases, from the up A, B, C, and to the bottom. Then our recommendation or the line study will speak for a solution to install the surge arrestor on the bottom phase, both left and right, 2 circuit, and also for the middle phase. Yeah, left and the right side, also the both circuits, or at least installed on one phase of the middle phase. So Kumar, maybe you can share also your more experience.
เป็นครั้งแรกเดียวเลยนะ
Yes,
Kumar?
actually, yeah.
Mm.
Here I can also see that the information which has been given against each tower is basically mentioning about the resistivity and not directly the tower footing resistance. So we may require the information about the earthing foundations, like the method of earthing, so that we can estimate the overall tower footing resistance based on the uh, type of method used for the earthing and the different resistivity at each tower. And yeah, as also earlier mentioned that in double circuit line, if we just install the arrestor on single side, all the 3 phases, it will improve the it will definitely protect against the double circuit failure, but we can't be sure that whether it will suffice the system requirement, because sometimes it happens that when there is a high tower footing resistance on the some of the towers, there will be any possibility that we need to install the arresters on both the bottom face of the tower, just to ensure that we protect that tower against back flashover, because back flashover will affect the bottom phases of the double circuit line. Then accordingly it will increase, because on the top there is a shielding wire we will install. So because of the shielding wire, it will somehow protect at the for the top phase and the middle phase, but there will not be a major protection against for the bottom phase against the back flashover. So it might be required that for some towers we need to install the arresters on the both the bottom phases.
So if we come back to the different configuration of EGLA, we have so many different scenario for the line study simulation. And the case 4, as we mentioned, the case 4 is we have a double circuit transmission line. On the top is the shielding wire, 2 shielding wire. And this blue square is the meaning of the surge arrestor. So recommendation speaks for that installation on the both bottom face and one of the middle face. Yeah, even better will be also installation on the 2 middle face of both circuit. So if you look at this figure and you just see how many towers will be installed on those high resistivity area, then multiplied by at least 3 times of the EGLA quantity. And in such a case, if you have, for example, 50 pieces tower, and on very high footing resistance probability, and then 3 times at least 150 units of the EGLA must be equipped. This is only example. No? So it's really depending on how many towers will have high footing resistance. And for those high resistivity area, if you see that the cost will be very high to reduce the footing resistance, then installation with the line surge arrestor will be economic solution, even cheaper than reducing the footing resistance.
Excuse me, may you go back to your conclusion on the whole study?
Yes.
Conclusion, you recommend the
Yes.
case L3 and L6.
Yes. We say the highest protection is installation 300 pieces line surge arrestor on the phase R2, R3, R6. R2, R3, of course, 2 lower phase and 1 middle phase.
How about L6? You install the L3 and L6.
Sorry?
The second grid line, the last case, you recommend this case, right? Solution, economic filter. Install only lightning rester only 2 units per tower.
Yes, yes.
And for the tower that have the ground resistance more than 5 ohm.
Yes.
And the failure rate tipping rate is 0 to 523.
Yes, yes. This is different result as a simulation.
One time per 100 kilometers per year.
Yes.
We recommend this.
That is also what we can make such a conclusion, or not the conclusion, is also the line study simulation result. Honsha says in their area they have only 67 kilometer line. Yeah. And if they install only 200 pieces, then based on the simulation, the failure rate will reduce to 0.23 times per year on his area. In his area, 67 kilometer.
So, but the total line length of whole size 67 kilometers only. Right?
I think this is the length of the Honsha responsibility. The other responsibility belong to the EGAT in Thailand area.
This project is the requirement is one time per 100 kilometer per year.
One time's okay, yeah.
Yeah.
Of course, if you have the target, we can, after we receiving the solid data, then we can run the software simulation. And we can also make the recommendation to reach 1 times per 100 kilometer per year, how many EGLA will be needed. But today is too early because we have no solid data input from your side.
Another question. One trip out per 100 kilometers per year. It means that we have two types of fall. One is the back flashover. One is the lightning strike at the conductor. It means the trip out your study include these two types of fall or just only back flashover.
No,
On
yeah, I
today's,
will take.
yeah, Kumar, please.
Sorry. Yeah, I will take this question. So yeah, basically this study will include both the types of flashover. Basically, just to answer your query, it will also consider back flashover and the shielding flash failure flashover rate, and also like if you have the transmission line installed with the shielding wires, so it will be very, I can say, shielding failure flashover rate will be very less compared to back flashover. So yeah, but just to give you an answer, it will consider it will take both the flashovers in a simulation basically.
ต้องบอกว่าเฟสโอเวอร์เนี่ยเทคโอเวอร์เข้ามาเป็นdirect มันน้อยมากมันจะสายแต่เป็น cover
แต่ไอ้นี่เราดูได้ดูช่องเห็นได้ว่าบอกน้อยเขาก็เขียนแค่นี้นะ
เราบอกว่าตรงกลางตอนข้างบนต้อง
แค่นี้ต้องมีคำตอบไม่มีคำตอบไม่มีคำตอบไม่ได้ตัวเลขมาตัดคำตอบในการ
ก็ต้องเราทำการล่างดูก่อนแล้วก็ดูต้นแรกๆก่อนว่าเรารู้ได้เท่าไหร่ Soคุณสุพล I think we after we start foundation we try to improve for the 1 or 2 or 3 tower first so we will know the ground resistance what we after we improve
ครับ
อย่างนี้นะแล้วก็เดี๋ยวค่อยส่งข้อมูลให้แล้วก็อาจจะต้องศึกษา2 ครั้งเหมือนที่ว่าครับ
ครับพี่
นะครับ
ได้ครับ Okay, Hong, the customer will feedback after they start for the footing, and then maybe they need some your advice again.
Okay. So they will start to reducing the footing resistance and see the consequence, yeah, see the result. Very well. What about roughly the schedule for the whole project? So you mean the starting construction will be next year?
Yes, and the foundation will be finished within 1.5 year.
The complete the transmission line.
No, I mean only foundation 1.5 years, and the total within 3 years.
Okay.
May I ask a question? I mean, would like to ask you for your experience. For the extra high voltage, like a 500 kV, do you have any information from the client that they use a continuous grounding material for the line? I mean, from one tower to another tower with the grounding material to improve the footing resistance.
Frankly to say, I have not understood clearly the question. And you mean from the other customer, which they have used?
I mean, for your client or your information, do you have any information regarding of some such a power utility that use or install the grounding materials with the continuous material crowding from one tower to another tower, because this project, for example, is very high crowd resistivity and very hard to reduce the footing resistance up to 5 ohm. It's very hard. And
Mhm.
then in case if necessary or uh, we don't have experience on this, if we install the grounding material like a counterpoint wire from tower number 1 to number 2 and to number 3 underground continuously, is it possible?
Unfortunately, we have not such information sharing with the customer. No? We have no experience or we have not information about it.
Okay, thank you.
In manufacturing of the learning lessons.
Yeah, after we finished the design and approval and delivery time from the factory or even go to, I don't know, where should be also the destination? Go to Bangkok would be roughly 4 months, for up to 5 months.
Your test factory.
Yeah, our factory will be in Wuxi, China.
Mhm.
Yeah, the EX work factory will be roughly, let me say, less than 4 months.
Less than 4 months.
Mm.
Mhm. The housing composite insulator made by your own or you purchase from third party.
Yeah, we made by ourselves because the polymer injection, we have a very huge factory in Wuxi and also a very huge machine to make the HTV silicon rubber injection.
คุณสมบัติครับมันมี2 section นะครับ section 2เนี่ยเราน่าจะจบ foundation ก่อนภายในปีหน้าคิดว่าปีหน้านะครับเพราะมันแค่30 hour นะครับ10 กว่ากิโลนะครับอาจจะส่งข้อมูลให้ก่อนแล้วก็ศึกษาเป็น2 section ได้ใช่ไหมครับ
พี่ถามเขาเลยเดี๋ยวผมถามเขานะพี่
Okay.
คุณประพันธ์ he said that there are 2 sections. The first section it is about 30 tower.
Mm-hmm.
So is it possible that to submit the first section to you for studying and then the next after? I think in total 330 tower ใช่ไหมพี่
ครับ
ครับ Yeah.
แรกมันแค่ประมาณ30
Is it possible that the
Yeah,
first
sure. Of
study
course, it's
30
possible.
tower?
Mm-hmm. So Kumar, it is also possible for you.
Yes, I think it should be fine, but just that we need the solid information. And yeah, if possible, please share our template of questionnaire to perform this line study so that we can get on all the information what we require.
ก็ส่งมาให้
พี่ประพันธ์ครับ questionnaire ที่ส่งไปให้ครับลองพี่ลองพิจารณาดูหน่อยก็ได้นะครับว่ามันต้อง input อะไรบ้างนะครับ
ได้ครับ
ครับ
ในโปรแกรมนะฮะพารามิเตอร์ที่ใช้ในโปรแกรมที่ใช้ในซอฟต์แวร์ครับถ้าส่งให้ผมจะได้ไหมครับผมจะได้รู้ว่าต้องเตรียมอะไรให้บ้าง
Uma, regarding your questionnaire, is it all thing that you need for studying, right?
Yes. Yeah, it's actually we have compiled all the necessary information we require to perform this line study, which generally requires the information about the conductor details and the tower footing resistance and the insulator details, like estimated details will also be sufficient. So yeah, then it makes easy to input all this necessary data into the line study and we get the accurate results out of it.
เขารับได้20เนี่ย
ครับตาม questionnaire เลยครับพี่
เข้าใจครับโอเคครับ
Mm.
So
Paran,
think-
one question from my team. Sorry,
Yeah,
one question
please.
from my team. What is the lightning current that you use for your software during the simulation calculation? Lightning current. How much of the lightning current?
Actually, in the lightning study, I can say there is a formula from the SIGRE study and the SIGRE paper that it uses a formula which has the statistical analysis which divides the lightning current throughout the different spectrum, like the different values will be applied on the towers, and based on the geometry and the insulator behavior on that tower, it will show me that how many back flashovers or at what level of the lightning current it will get flashover, and how much rate of the back flashover will be uh, there if we don't install any surge arrestor. And then after, if I add the arrestor installation, how much improvement we can get throughout that statistical study, that will be showcased by line study also. And also, in addition to the statistical analysis, we can also provide a specific magnitude of the lightning current with respect to, also we can also add the waveform of it, like if as per the standard for the um, EGLA standard from the IEC, there is also a high current standard, high current values of 100 kiloamps with the waveform of 4 by 10 microseconds. So we can also give an input with this magnitude and the waveform also, and we can get the results that how much impact is it has on the specific transmission tower.
Yeah, thanks. But yeah, normally in many of the papers, the reference technical paper, mostly they uh, refer to the magnitudes of about 100 kA maximum, something like that. But from your technical specification of your EGLA, it seems that the maximum nominal discharge current is 20 kA. Is that the same thing or a different thing? I mean, the
No,
lightning.
it's actually different. I can say a waveform of a surge arrestor. If you see that maximum nominal discharge current, it has the waveform of 8 by 20 microseconds. But if you study the lightning impulse waveform, it is basically a 1.2 microsecond divided by 50 microseconds. So it has a different wave shape. So it will differ in terms of the magnitude also.
Okay, good.
Okay, I think we over the time. Any question from พี่ประพันธ์ครับ
ไม่มีครับ no question
Thank you very much.
we will send you the information after we finish the second tour first
thank you ฮง thank you ครูมาขอบคุณมากครับ
Thank you.
แล้ว
ที่
ขอบ
ให้
คุณครับขอบคุณ
Thank
ครับ
you
ทุ
for
กท่าน
time.
สวัสดีครับสวัสดีครับ
Thank you.
สวัสดีครับ
Have a nice day. Bye
Have a nice
bye.
day bye
Bye bye.
Birthday, bye-bye.
ให้คุณผู้ชมครับคือบอกว่าเราต้องรู้ว่าเราควรจะได้ถึงเท่าไหร่ก่อนนะครับส่งให้เขาไม่งั้นเรานะไม่งั้นมันตอนนี้มันก็ต้นแหละถ้าเสร็จตอนเนี้ยมันก็เอาต้องทดลองก่อน
อย่างที่บอกครับเขาศึกษาเนี่ยเพราะเอาแม็กซิมัม
ใช่แม็กซิมัมเต็มที่เลยครับต้
ต้
น
น
แห
แร
ละ
กแล้วมันช้าเนี่ยอาจารย์บอกว่าต้องการสุด
ใช่
ไปว่าเขาไม่ได้ แต่นี่เขามาคิดว่าเราเหมือนกัน
ไม่ใช่แล้
แล้ว วก็เขาก็จะคิดว่า เราทำสายเสร็จแล้วแต่มันไม่ใช่
ใช่
แต่ว่าเขาไปรับในตัวซอยมีซิสเต็มที่
ครับ
มันจำไม่ออกไม่รู้เรื่อง
นะครับ
แค่สุดเรื่องไปแต่เรามีหลายเรื่องนะเพราะว่าตามตัวหนังสือแล้วเนี่ยเรียนหัว
เก็บกับอะไรมาฟังเก็บคู่คน
เพราะนั้นเราต้องเป็นตึกแล้วก็เดินเข้าระหว่าง
ครับ
แล้วพลาดแล้วมันกลายมาเราเบิ้ลทุกสัป
ใช่
ดาห์ที่จะถึงเนี่ยกลายแบบเบิ้ลจะมาส่วนเราที่เขาเปลี่ยนไปเปลี่ยนมาเรื่อย
ผมว่าเราต้องลองปอดสักของเครื่องนะพี่ผมจริงว่ามันลดได้กี่โอห์อาจจะต้องลอง2-3ต้นนะ
ดูทีดิก็มีความยาวของสายเนี่ย
แพงมาก
ไม่ใช่มันยาว600 เมตรมันเกินสแปน
เคต่อถึงต้นนี้ต้นนี้ ต่อต้นนี้มันไม่ไหวแล้วมันแพงนี่
ขอสแปนเนี่ยได้ถูกกว่าอีกอะไรนี่เวสเตอร์แต่ว่าสายมันยาวเกิน
มันทำไม่ได้ด้วยพี่มันทำไม่ได้เพราะว่าเราไม่สามารถเดินขุดดินตามแนวเนี่ยแนวแล้วเนี่ยเพราะว่าจะโลกภูเขาเป็นนี้เลยจะโลกภูเขาเป็นนี้เราจะขุดฝังกราวไปตามดินเนี่ย
ไม่ได้
แล้วไปได้พี่แต่ว่ามันตลอดแนวมันไม่ได้เพราะมันเป็นเหวมั่งเป็นอะไรนี่มันไม่สามารถเป็นไปได้
เป็นลึกลงไปเป็น
ใช่ครับ
obstruction อย่างเงี้ย
ใช่ครับ
ใช่ไหม
ใช่ครับแล้วสมมติไปข้ามถนนสมมติได้ข้ามถนนข้ามรถไฟทำยังไงมันก็ทำไม่ได้อย่างนี้มันทำไม่ได้มันไม่ได้ใช้ง่ายที่จะทำต้องเดินไปตลอดแนวคือเสียงคลองที่แม่น้ำก็เข้าไปไม่ได้แล้ว
เทคนิค2ในทางที่ลาบก็ค่ตรงเนี้ยใช่ไม่ลาบเป็นภูเขาเหมือนกันครับภูเขาเหมือนกัน
เหมือนกันครับแต่ว่าเตี้ยกว่าทางใช่ไหม
เที่ยวของ
ครับเป็นคนเคสตัวสีเดียวทำไม่ได้อยู่แล้วยกเว้นว่าเป็นบางช่วงได้คืออาจจะ1 ต้น 2 ต้นที่ทำได้โอเคเคสต้น
ผมเรียนแต่ของเราผมใส่ต้องไปให้ด้วยเนี่ย
ครับ
คือมันเป็นต้องเป็นฟิสิกส์ว่าถ้าสมมติว่ามันยืดแล้วจะพอยไปสัก200 เมตร
ครับ
พอจำได้
มันลดเท่าไหร่
มันลดเท่าไหร่ใช้มาจบมันก็ติด
ใช่ครับ
ใช่ไหมว่าสถานที่เนี่ยที่ก็มันไม่เห็นมันต้องให้ใครไปดูว่าเฮ้ยนัดได้200 เมตร200 เมตร
ครับใช่
ต้องไปทำรายละเอียด
ใช่ครับ
ไม่ดีก็คือ
ต้องนั่นก็คือเราต้องทำต้องระยะของจริงไหมพี่ระยะหนึ่งอาจจะได้5 ต้น 10 ต้นก่อนนะครับแล้วก็ลองไปดูกราวทำกราวสัก2-3 ต้นหรือ5 ต้น 10 ต้นเนี่ยทำกราวให้ดูว่ามันเป็นยังไงเป็นการศึกษา
เราคำนวณมันไม่ได้เราเอสเกนมันเขาทุกพอยต์ไป
ครับพยายามให้รู้ด้วยพยายาม
ดู
พยายามทำให้
ลูกแคลคูลเลชันเราพอผม
ใช่
แต่
ครับ
ใกล้เคียงก็อย่างก็ตามเราจะเคียงต้องเขียนเนาะเป็นอยู่
ใช่ครับนั่นแหละมันมีสิทธิ์ลดถึง5 โอห์มแล้วก็ทำต่อถ้าไม่ดูแล้วไม่มีทางก็
ผมก็ชวนมาทัวร์ประเภทมันเขียนนั่นแหละ
ครับ
ผมลดให้ได้หนึ่งตุ่มใช่ถ้าโอมก็ทำไม่ใช่แล้วเนี่ยบอกผ่านไม่ได้200 เมตรที่มันได้สัก20 ต้น
ใช่ครับใช่ครับ
ที่เหลือมันเกิน200 เมตรไม่ได้
ไม่ได้
มันก็ไม่รอด
ใช่
ก็ทำฟรี
ทำใช่นั่นแหละต้องฟรีนะไม่ต้อง
ว่าจะทดสอบไม่ว่า แต่ว่ามันจะเกิน200 เมตร
โอเค
ได้
ไปตัด
มัน
มา
จะเป็น
ขอไม่ต้องว่าข้าวแล้วก็รู้
มันจะเป็นเพราะว่ามันใช้แอป
เขียน
เพราะอะไรขาดที่ไม่รู้นะ
ลองเช็คกล้องว่าเชื่อเก่ง
คือบอกต้องทำแล้ว2-3 จะรู้ว่า
จบข่าว
เขาจะพอไหวไหม
ยิง
ถ้าทำแล้วมันไม่รู้แล้วบอกไม่ได้ตอนแรก
ตอบได้เลยคอสแต่คุณยังสั้นเรา200 เมตรมันได้แต่ที่
ที่โอมันทำใช่พลังเราไหม
100 โอห์มเมตรใช่ไหม
อ๋อ